This video is going to be about me modifying the Lathe Dog to turn these parts between centers. I went to the tool supply place on Saturday and I couldn't get the right size one. They didn't have it in stock, so I had to get the next size down and I have to modify it, and that's what's going to be in this video. It's going to be kind of almost a vlog style video. I'm hand holding the camera in a few shots and this, so it's a little bit shaky, but I think you'll get the idea. So enjoy the video. Okay, this is where we're at. I spotted all the end holes on these parts here. Got all the chamfers and all the parts, but now I have to rig up something to turn them between centers on the lathe. Now the parts are kind of short, and so when I bring that steady rest up here and the tailstock, if I just use this chuck, the part's too short and I can't get the tail center up in here far enough on that. So I was going to use this chuck it extends it out, so then the end of my part's going to be out. If you can see it, the end of my part's going to be out here when I machine a center on here to take that hole in the part, and I can get the tailstock up to it there. But with it up here, with the steady rest in here, that mount for the steady rest over there in here, I can't really get the center up to the part. So I'm thinking about how to do this, and I've got these two driving dogs, but this one fits on the stock as it is. But the problem is, if this were the stock, this is a little bit smaller than the stock. This is like a 3-inch round bar and the stock is 3 1/4, but this one would fit on the stock. It's got plenty, but you can see my problem here. The arm is too long and it won't catch the jaw. So I went down to Bass Tool this morning and they didn't have something in between these two sizes. They only had this one in stock, and it fits on this 3-inch diameter and it would hit the jaw, assuming I machine the center close to the chuck here. But the problem is that this here, if I take this over here to the material, we look at one of the parts here, it won't fit on the stock, the bar, because it's a little bit too small in the bore here. If it was just an 1/8 of an inch bigger or so, maybe, or just a little bit bigger, it would fit. So instead of having to build one of these things, it was cheaper to buy this. This thing was like $18, I think, something like that. So that's pretty cheap, but I have to machine the bore out a little bit on that, which is not that big a deal to machine it, but how do you hold it? That's the trick here. I think I'm going to take this piece out of the chuck and go over to my storage and weld it. Just put some heavy welds on the back here somewhere, like maybe here and on the other side, or I don't know, weld something in between here, maybe even like some nuts or something, and weld the part onto there so that I can machine out this whole inside and take it to a bigger size, slightly bigger size, and make this thing work. Otherwise I got to build a whole driving dog, and that's too much trouble. I think this will be easier to do. So here, we're going to take it over there and go weld it up. This is a big part in the lathe here. Pretty good sized part there. Kind of looks like it might work. Let's see. See how it's on there pretty good. So it's getting kind of late in the day today. I think tomorrow we're gonna program this shape that we need to fit the stock of the parts and mill this all the way out down to here. And these nuts should still hold it on. And once we get it milled away, then we'll just break it off of there. Here we are in the CAD software. We're going to draw a shape to represent the programming path that we need. So I'm going to select this work plane to draw on, because I know this will position properly in the CAM software. I'm going to draw a circle that represents the, it's going to be 3.25 inches in diameter. This size represents the shape of the part. I'm going to turn that into a construction line just so we get an idea of what we're looking at size-wise. And I'm going to draw the actual shape of the driving dog. The inside of the driving dog was 3.085 in diameter. I'm going to draw a construction line that comes off tangent and horizontal to that. I'm going to offset this 3.5 inches. This is where the point of the driving dog was, the way I measured it, the existing point. Here's I'm going to draw two tangent lines to that circle up to the point. So this represents the shape of the actual driving dog as it is right now. We're going to select that whole profile. We're going to offset it this will be to the part, but we want to offset another 50 thousandths, we'll say, of an inch. So we have a little bit of clearance. Went the wrong direction. Start over here. We want to offset 0.1352, I think is 50 thousandths larger if I did my math right in my head. And then we're going to cut this, we're going to get rid of this profile because we don't need that. And we're going to draw a corner round in here in this corner of say 3/8 of an inch. So that's the profile we want to machine. Now, in order to draw a solid of this, we've got to have some kind of a shape around that to extrude. So I'm just going to pull a rectangle around that. We're going to get rid of the middle of this. And we're going to extrude that, and I think I measured that at 1.230 thick for the driving dog's shape. It's actually a casting like you've seen in the thing already, but we want this inside shape we need to program to, so we can program a milling profile around that in the CAM software. In this software we got to define a pocket thing here. We're going to select this, change our work plane to that work plane, the YZX they call it here, and we got to define a feature that's a pocket right there. So that's our feature here. You can see it right there. So now we got to define a tool of some sort. I think I looked in the tool changer in tool 41. I'll just make a new end mill, tool 41. Well, actually it's already defined here. I must have used it before, except I have to put it in the spindle, the proper direction. Okay. Now, just to make this super easy, because we don't want to get too complicated here, we're just going to do a milling cycle we're going to try to do it all with a pocketing cycle just to make it easy. And we're going to do a rotary face pocketing because we have to rotate the C-axis to do this. And we're going to use that tool. So let's watch a simulation. One more time here. You can see the chuck back there. I defined the chuck way back there just to get it out of the way. We're doing this just because we got to rough the whole rod away as well. That's the part sitting, or it was originally clamped on, I should say. It's only going to really be cutting about, I don't know, maybe 1/8 of an inch of the part at most, really. I reduce the depth of cut just so we don't get too carried away and break the welds, or the part vibrates or something weird like that. That's why I slowed the RPM down so much on the finish pass too. I'm not really sure how steady that part's going to be after we machine all of this rod away. The reason I'm machining it this way instead of just doing a straight pocket without rotating the C-axis is this machine will only travel 10 millimeters minus in the X-axis. So you can't machine a shape like this on this machine and just do it straight in, because you'll run out of X-axis travel. It'll hit the travel limit. So you have to work everything above in the plus direction on the X-axis. So you have to rotate the part like we're doing here in the, it's got one more pass to go in the C-axis. If I was to zoom back and that chuck on, you could see the chucks rotating here. Of course, the material definition doesn't look like the part, but it doesn't really matter for the purpose of programming. We just want to do this inside cavity. Make a 0 point for our C-axis somewhere. So we're going to set the C0 there. And then we're going to touch the Z off down here. But we have to rotate the part around to do it, because we can't jog down here in this machine. So we can touch the Z off here somewhere, because the whole part is, the whole front of this slopes. So we got, we just got to get a Z somewhere here. So we'll touch it off right here. Make that our Z0. Purpose of this setup. Okay, here's the actual machining operation. I'm going to switch to that, what was it, tool 41, I think, if I remember. I'm going to come down here, and I was able to I ran the first couple of passes without coolant, so you can kind of get an idea of what's happening here. Because when you'll see when I turn the coolant on it, you can't really see too much of anything. So I'm only taking, like I said when we did the programming part, about 1/8 of an inch depth of cut per pass, just to, I don't want to tear that thing off of those welds and have problems, so I just wanted to take it easy. That piece of steel, I think, that I welded this thing to is like a piece of commercial heat-treated 4140, and it's kind of tougher than I thought. You saw the sparks fly off the end mill. So yeah, as you can see, the coolant kind of blocking everything here. You can kind of see what's happening. I tried to get various different angles, trying different angles with the camera to get better shots, but it's just difficult. I stopped to check to see what I was doing, and everything seemed to be lined up pretty good, so I continued going. It's I wish I could get, I don't know, I wish I'd get something that would really get that coolant out of the camera, but I mean, this is working pretty good. The GoPro little case is working pretty decent. I mean, you can kind of see what's happening there, alright. But with all this coolant in the machine, it's kind of difficult to get a decent shot of this. But you can pretty much see. And it actually worked pretty good. It's doing the finish pass right there, so it's almost done. And it held on pretty good, actually. So there it is. It left just a little bit right there in the bottom of the V that I had to, and it broke out of there. The casting is supposed to be a steel casting, but I don't know. I broke the nuts off of here. And that actually went pretty good. Wasn't too bad. So there's the finished machine work, but you can see that little kind of, I don't know, the camera was focusing on the chuck back here. It's a little bit blurry, but you can see the little
bit of
flashing it left there. But that came off pretty easy. Actually, I just kind of broke it off with a wrench, a crescent wrench.
Finished part. I don't know if this was like a cast iron or something, the way those broke off of there. These are supposed to be steel, they say. I don't know. I don't know if you can see how that broke off of there when it's in the lathe. It's going to go this way.